Welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the Program Manager for the Recycling Market Center and will serve as your moderator today. Before we get started with the presentation, we would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series. The focus of today's webinar is on the WARM model. Today's presenter is Nathan Wittstruck, who I'll introduce in a moment. Following his presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you're experiencing any technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. The presentation slides can also be obtained using the handout upload feature on your webinar control panel. And now I'd like to introduce our presenter. Nathan Wittstruck is an economist with the US EPA Office of Resource Conservation and Recovery. Nathan's experience includes promoting sustainable materials management, working on e-waste issues, and developing voluntary consensus standards. Nathan also spent 1 year in the international branch supporting work on key environmental issues in the US-Mexico border region and with the North American Commission for Environmental Cooperation. Currently, Nathan's primary role is the management of the WARM tool, which includes stakeholder engagement and overseeing technical improvements to the tool. Nathan has a master's degree in economics from the University of California, Riverside. Okay, Nathan, I'm turning it over to you.
Okay, thanks a lot, Wayne. Thanks everybody for participating. I'm glad to have a little over an hour to go over the WARM tool with you. I'm based out of the EPA headquarters office, and I work under Cheryl Coleman and Ron Vance, in case some of you have worked with them. So the three main things I want to make sure that we cover are to give an overview and some background of the WARM tool. I've been managing the tool for just a couple of years, but it's been around a significant amount of time, so I want to provide some of that background. Then I want to ensure that participants feel comfortable accessing the tool and using it to report results. I'd like to do a couple simple walkthroughs of inputting data and seeing results. In case some of the users haven't actually done that before, it'd be good to see firsthand. And then for those that have, you may spring some questions for the Q&A round. And then lastly, I'd like to provide some updates on the future of WARM, where we're going in the next year or two, so that you have a sense of what to anticipate. So as I mentioned, WARM has been around since 1998. That would be WARM version 1. Every year or two, we do an update of the data, add new materials, and we're currently on WARM version 14. The WARM tool is designed to calculate baseline and alternative waste management practices. So the management practices we have modeled in WARM currently are source reduction, recycling, combustion, composting. The newest one that was added is anaerobic digestion, and then landfilling. And we currently have 54 materials modeled, and so there's a wide variety from paper to plastics, organics, metals, and they do primarily focus on municipal solid waste materials that you'd find in municipal solid waste. And then we have added significantly to construction and demolition materials, as those have been an area of focus. There are some things that we don't have, and so we get feedback from stakeholders about things they wish they could model, and occasionally those come with sources of data and other things that help us do that more quickly. So we are happy to hear things that you wish could be added. I want to talk just for 1 minute about how results are reported in WARM so that people are clear. There are 3 ways that your results can be reported. They're metric tons of carbon equivalent, metric tons of carbon dioxide equivalent, and energy units. So you can see there in the middle that metric tons of CO2 equivalent is in bold. That's the way that emissions are most widely reported and often used by stakeholders. And what that does is takes a number of different chemicals and provides an equivalency. So over the 100-year time frame, you can see on the left the chart, CO2 would be at 1, and then the second one, methane, would be in this with AR4 25 times as potent of a warming agent. And so for each unit of methane release, that would be 25, the equivalent of 25 of a carbon dioxide unit. What this does is allows us to report on a number of different emissions, not just one singular emission, and it helps for the results to be more complete. It's important to note that currently the WARM tool focuses on GHG emissions, but doesn't include environmental impacts outside of emissions, things like toxicity, the impacts on water use, and other environmental impacts that are very valuable, but just not currently modeled by this tool. We are working on ways to potentially incorporate other environmental impacts into results, and have other tools at other parts of the agency that address some of those as well. One more slide on the results and this is a visual from one of the documentation pieces for WARM. And if you start in the middle with the raw material extraction, this walks through the process and gives you an idea of where some of those impacts can happen. So there can be impacts from that extraction itself, the processing of the raw material into a product that can be used in the marketplace. You can see also the truck of the new product. There's a transportation emission associated with that. And then at the end of the life, the paper can either be recycled or could be disposed of in a landfill. And so if you go to the bottom section, the recovered recyclable material often has less of an environmental impact than the raw material extraction and processing into a material. And that's where WARM starts to compare the differences in sending to a landfill, which has positive emissions, or the comparison of generating a product from a recycled or recyclable material or from a raw material. And so these are some of the areas that are captured in the WARM tool. So there are a number of ways that the WARM tool is used. I want to give a couple examples, and then I'll show the tool itself and then do an example. This is one that compares per metric ton the metric tons of CO2 equivalent per short ton. And so in just one quick snapshot, you can see the materials that we're looking at here are food waste in blue, so it's blue throughout, yard trimmings, and mixed organics. And so here at the bottom, you see the different management practices. And so you can see that by composting all three of these organic materials, that there is a net negative impact. And so what that says is if anything above the x-axis means a positive emission to the environment. So in this case, a positive emission can be adverse and something we want to avoid whenever possible, whereas the negative results are something that's saying that there is less of an emission or a reduction in the emissions to the environment. This is something we get questions about a lot. That when you make change to a management practice that has positive impacts, that your results in WARM are actually negative. So it shows that there's a reduction in emissions. So this is a quick snapshot. If you have one material you want to look at, you can look at it across the different management practices to compare. At the EPA, we do have a waste hierarchy, both for food waste and for general materials. And when you compare these management practices to source reduction, you can see for the food waste category how significant the impact is if you consider source reduction. And so when we talk with stakeholders, it's important that source reduction is part of their management practices and that they're considering that whenever possible. One more here with looking at some other more general recyclables. So here the products or materials are grouped together, and you can then see the different management practices side by side for each individual product or material. And so, for example, for aluminum cans, you can see that the source reduction impact is significant, that there's a large net negative for source reduction, but also for recycling, that there's a huge impact of recycling aluminum cans, and a lot of that has to do with offsetting the raw material extraction and processing into aluminum. You can see that then for glass, by comparison, on a per ton basis, has less benefits per ton to do that, but also can be very important because there can be a lot of tonnage available of that material. And so you can see for a plastic example, newspaper, and then mixed recyclables, which is a combination of materials. We have mixed categories often for users who aren't sure of the exact makeup of their mix of materials, and so we do have a mixed that captures a number of different types of materials. So in the WARM tool, in the Excel version of the WARM tool, I'll get into the two different ways that a user can interface with the tool at the moment, but this is a way that you would see the results at the top. So at the top, within this box, you see the total GHG emissions from baseline, and I'll explain in the example what the baseline versus alternative means. But you can see that there is a net negative emission from what's chosen in the baseline of 444. And then the alternative management practice, there's a significant net negative at 2,825. And what WARM does to calculate the difference between those and your result is it takes your alternative practice, so what you have moved to or intend to move to, how you intend to manage the material, subtracts the result from the baseline and gives you the difference as your total. So by moving from the baseline, what you did initially, to the alternative management practice, there's a benefit of or a reduction in emissions of 2,381 metric tons of CO2 equivalent. Now, one thing that's clear is that negative 2,381 metric tons of CO2 equivalent doesn't resonate with a lot of stakeholders, users, people in the public, and they want to have something more tangible to understand. So, for example, there's an additional tool that I'll show where you can use a metric ton of CO2 equivalent and get an equivalency. So in this example at the bottom of the slide, you can see the benefit of recycling 1,000 tons of recyclable material rather than combusting that 1,000 tons is equal to, and then there are, I think on the website, there are about 20 to 30 examples of things that is equal to. And so things like removing 500 passenger vehicles driven for a year from the road is something that can easily resonate with somebody in the public. Equally, power a home, 251 homes. So things like that are important in messaging. So when you look at the area to input tonnage into the WARM tool, you can see here, this is a screenshot, that on the left-hand side you have the material. So starting with aluminum cans, and this is only a partial list. It would go down beyond food waste, non-meat food waste. And at the top you have the management practices. The blue cells, so everything that is blue is a cell that is modeled. So for aluminum cans, recycled, landfilled, and combusted is modeled, but composted and anaerobic digestion is not modeled. In most cases, those make very clear sense that I don't think anybody is composting aluminum cans, but there are cases where it is a management practice that could be happening, but we may not have data on it, and so in that case, it's not modeled. Some users run into issues when they're trying to model a cell that has the NA and are told that they're not allowed to, and trying to understand why. So I would like to do a quick example here. So if you type in EPA WARM tool, a number of things like that, you'll get to the page that has the WARM versions. I guess I could do this so you can see as well. So here's the general category for results for WARM. And if you click on versions of WARM, this pulls up the actual tool. There is a significant amount of documentation, frequently asked questions, related topics and tools. So there's a lot of information within the WARM general area. Here you can see the different versions. We try and keep as many available as possible, along with a general summary of what the significant change was between a version. And down under warm version 14, there are two different ways that a user can interface with the tool. There's an Excel-based tool, which I'll show you first, and then I'll give an update on Warm OpenLCA, which is newly released this year, and I'll also do a brief walkthrough with that so that you're clear, because while they're both available and will for the near future, there will likely be a time in the future where only the OpenLCA version will be available to use. So if you clicked on this Excel-based tool, you would be taken to the Excel tool. One important thing to note is that while often users open and jump to where you enter data, there is a user's guide included within the workbook. So a lot of basic information about the tool is here, and reading that can answer some questions potentially, or lead you to where you can ask questions if you do have specific. That inbox comes to us. We try to answer as soon as possible. Usually within a week we have an answer, but it depends on the complexity of the question. So for the entry page, again, you can see that you have the materials on the left. This first group is the baseline. So this is what you are saying would happen if there was no intervention, or if you want to compare 1 year to the next year or to the previous year, you could put what you did 1 year in the baseline and in the following year in alternative, and that would be a way to compare them. Often users put the baseline, they default to landfilled, and so they want to compare whatever they're doing currently to what would have happened if it all went to the landfill. And so for a simple example, you could do 100. It's important to remember that this amount is tons, and so there are certainly users and households and others who have a small amount of waste but would like to model this, and we do have ways that they can do that and get an estimate based on a smaller amount, but the tool itself is made to tons is the unit. So you have 100 tons landfilled for aluminum cans as a baseline. You can see generated here is 100, and that means that on the right side, on the alternative side, the sum of the different cells needs to be 100 as well. And so in this case, we could say that instead of sending 100 tons to landfill, you recycled all 100 tons. Now, these are the rest of the materials on the left side. You can see that the blue cells are scattered throughout based on the material. Now down below, there are a number of ways. WARM in general is a national level tool, so we try to use averages that apply to the entire country, but there are some ways that you can tailor it to your needs. So for example, you can choose the state where you're located. And then what that does is provide a different type of electricity mix based on the region that you're located in. So it's not necessarily state specific, but could change depending on which part of the country you live on and how you get your electricity. And the reason that's important is a lot of what happens, if you move to recycling, there may be less electricity needed to convert a recycled product into a new product than to create that product from raw materials, and there may be significant electricity savings, and depending on how you generate that electricity, that would have different GHG impacts. Another way, so these are all ways that you can tailor your results to better match your specific situation. Another one that people often use is the transportation distance. So one question that people may be asking is, well, if I landfilled it in the past, it was only 10 miles to get to the local landfill. Whereas if I wanted to recycle it, I may need to have to travel 100 miles per truckload that I'm sending. And so you could include those types of things and see if there's a break-even point, or if transportation actually has a small impact on your overall results. So now that you have your information and entered, you click the next tab, which is a summary report. And so what this has is On the left side, it shows the tons landfill entered under baseline and the impact or the GHG impact of landfilling 100 tons of aluminum. So you can see here it's positive 1.86 metric tons of CO2 equivalent. At this point, this doesn't take into account the alternative scenario or any of the recycling benefits. This is just the impact of landfilling those 100 tons. Then on the alternative, you can see that similarly the benefit from recycling 100 tons is not negative 909 metric tons of CO2 equivalent. So your overall result is negative 911 metric tons of CO2 equivalent. Now, if you scroll down, there are a couple GHG equivalencies provided to the user. The website has many more, but this just gives you a few other equivalencies in case in a snapshot you want to be able to provide that to users. So this is metric tons of CO2 equivalent. There is a more detailed page that provides those same results, and then also some details about exactly how those emissions are calculated on a per ton basis. So this can be important for some users who are really digging into the data behind their results. And so there really is a lot of information, but most users do end up using the top level data. As I mentioned, you can get results in BTUs. So here's similar to the results for BTUs, and then metric tons of carbon equivalent rather than CO2 equivalent. So that's a quick example. I'll do one other more complex example in a second, but I want to talk about warm open LCA before we do that. So we have gone through a couple years of working to update the tool, and this isn't a changing from one version to another, but changing the user interface and how the data behind the tool is organized. And so what we've gone with is warm open LCA. So open LCA is an open source software that specializes in life cycle data. So rather than having all the data behind these results in an Excel worksheet that really is not something that we've been able to share with users because it's complex and involves a lot of data. The database and the data that we have in the OpenLCA tool is something that will be in a format that we'll be able to more readily share with users. That in the future, the idea is that users will be able to download that data directly, make changes to it if they have additional data, or they feel like some data isn't specifically relevant to their situation, and then still run the model using their information and the warm data. It's also interoperable data with other tools and programs that our agencies using. There's a federal LCA data commons that we'll be working to get our data into, and that's housed by USDA, but there are a number of agencies that can feed data into that. And then it will allow us to make future updates and improve the tool. One of those I mentioned is that currently we just have a GHG equivalency as the result, but hopefully we'll be able to work towards having multiple environmental impacts. So some of those things like toxicity, eutrophication, the impacts to water generally, things like that. So what all that really means is that currently there is another user interface, another way that users can interact with warm. And so it gives you the same results as the Excel version. And so it's similarly called version 14. But the user interface looks cleaner. It's a little easier, more intuitive to walk through. I will do the same walkthrough we just did with this one as well. And at some point, this may be the only version as the capabilities begin to diverge. So this is sorry for skipping ahead. So this is the input tab. So you can see again that the materials on the left, the baseline and alternative scenarios are similarly laid out to the other tool. One difference is that rather than scrolling down to add the specifics to your situation, you can see further characteristics is step 2, and so it walks you through stepwise a bit more how you enter your data. The results again are a bit cleaner than the Excel tool, so you can enter your company name, and it would add that information here in case you wanted to save these and run a number of different reports or each year. Here's the results for an aluminum can where part was source reduced and part was recycled, and then the GHG equivalencies here. So I'm going to go out and do the same thing I just did. So from the WARM website, you would just click here for the OpenLCA version, and you would download a zip file that you would need to unzip and install onto your computer. Once you did that once, you would have access to that on your computer indefinitely until there are updates needed. And then you would have the tool and access to it whenever you wanted. So similarly, the materials are on the left. So if we want to do the exact same example we did, we would do 100 for tons landfilled. You can see now that there's a pink highlight on this row, an exclamation point. That's letting me know that it's currently an invalid entry, that the alternative scenario need to be the same. And so one question people have said is, but what if, let's say, I only recycle 50 tons? Well, if you're still landfilling 50, you would need to still put that 50 in the landfill so that the total is 100 on each. But in this case, we're going to move all them to 100. Okay, so we have 100 in each. We can press next. For the further characteristics, this is the transportation or the physical location, and so we'll do Pennsylvania again. For the distance, we would put 10, and for recycling, it's 100. There are a number of other ways that you can tailor this, as I mentioned. Here's the area where you could enter your organization name if you wanted to print out something or send something to stakeholders that had your company information in it. And then here's where you choose how you would like the reporting units to be in. So if you went with metric tons of CO2 equivalent, you would press calculate. And so you can see from the baseline, you have the 100 tons and the results of that, which is a positive emission. The 100 tons recycled with the negative 909 metric tons of CO2 equivalent, and then the overall, which is the difference, and some of the equivalencies. Sorry about that. Let's go. So if we took the overall result, which is negative 911, so this is the greenhouse gas equivalencies calculator I mentioned. So if you type in GHG equivalencies calculator, it comes up. Once you click on it, into your data. So what you need to know is what data you have. And so in this, we have metric tons of CO2 equivalent. There are a number of different ways or the data you may have. So we have negative 911. And then once you have that information, you simply press calculate. And these are all the equivalencies that it provides for you. Guess it may be more intuitive for users if you switch it to the positive. So it says how many, and so recycling 100 tons of aluminum cans rather than landfilling it is equal to taking 195 passenger vehicles off the road for a year. There are a number of different equivalencies, so depending on your audience, you could change that. Before I end the demo part, I did want to show a bit more of a complex type of entry you can make. So one of the goals that we have here at EPA is to reduce food waste going to landfill by 50% by 2030. And so one interesting thing is to model, what are the different ways that we could reduce that quantity going to landfill. And so you could here have the baseline where you have, this is from EPA's Facts and Figures, Sustainable Materials Management Facts and Figures report. So we track a number of different materials annually and report on those, usually with a 1 or 2 year lag. But here we're talking about millions of tons. And so, the baseline is we have the vast majority of food waste going to landfill. We do have some combustion and some composting. And then what that may look like if we had, only 50% or less going to landfilling, what's the capacity? That could be one way that you could decide where to put these quantities. This specific example has a significant amount going to composting, with some increase to combustion, increases to anaerobic digestion, and some source reduction. And then with large quantities like that, you see, there are really huge environmental impacts of doing that. And so while there are positive environmental impacts on both, because there's still a significant amount going to landfill, you can see that when you look at the difference, there's also a huge, 13 million metric tons of CO2 equivalent. So they become really important ways to reduce environmental impacts. One thing I haven't done in these examples, you can also enter under a number of different materials within the same calculation, and then when you get to the results, it'll break those out for you. Okay, let's go back to, so that's an overview of what, how to use the tool, how to access the tool, enter information, and interpret results. What we're working on now is moving from version 14 to version 15. One of the main things that we'll be improving is updating the electronics category. Currently, to model electronics, what you have is if you enter tonnage under electronics, you're modeling a 70-pound desktop computer. That's been out of date for at least 10 years, if not more. And so we're looking into the best way to capture the varied types of electronics currently in the material stream. So that can be, we need to incorporate phones, small devices, a number of different types of components. And so that's something we'll be adding in early 2019. We'll update the overall emissions factors behind all the results. We will maintain both an Excel and OpenLCA version of WARM at this time into version 15. For those that are more comfortable with Excel, it's important for us that they can continue to use that. And then we'll also be drafting a memo, and that's kind of our first step in making improvements to a category management practice. And so that memo will look at new information about construction and demolition materials and the ways that they're being managed, and look at gaps that we currently have if we need to add materials or management practices for the existing materials. Another big add for version 15 is that for the first time, your WARM results will include an estimate of the economic impacts of diversion. And so it'll compare things like avoided tipping fees, the value of the commodities that you've diverted and are able to reuse and resell, even things such as potential impact on jobs. A lot of states, we here at EPA headquarters also did a national level analysis of the impact of the recycling industry on jobs. And so some estimates like that will be included for the user to get a sense of a more complete sense of the impact in addition to environmental impacts. So at this point, I'd like to leave for questions and be happy to jump back into an example or field general questions. We do have a team here at WARM that we field questions. My colleague Tyler Rubai and I field most of those. But depending on complexity, we are supported on this through a contract with ICF International, and so we do work with their team as well to answer stakeholder questions.
Okay, thank you, Nathan, for that Great presentation. We're now going to field some questions for Nathan. Again, if you have a question, please enter them onto the GoToWebinar dialog box. And Nathan, feel free to scroll back in your presentation to refer to some of the slides, because a lot of these questions do relate to the questions. So,
sure.
So the first question has to do with integration. Is there any, does the tool integrate with any other programs such as WasteWise and Energy Star Portfolio Manager?
Yeah, so I'm sure that WasteWise and Portfolio Manager are using warm emissions factors. And so how that works is we work with the folks who are running those tools and provide the data behind warm in a way that matches their programmatic needs. And so I think that both Portfolio Manager and WasteWise get some environmental benefits of their program, and both of those are from the warm emissions factors behind warm.
Okay. Does the tool enable the conversion for metric data, or do you have to convert that before you input it?
Yeah, the input is short tons, so you would need to convert it. So here in the cells, what you need to input are short tons.
Right. Do you have waste profiles by verticals? Example given is 35% of solid waste in hospitality is food waste.
So like, would we have a category for hospitality?
Yeah, I guess kind of establish your baseline, and maybe when you estimate waste out of a waste stream, are those profiles available somewhere on the website?
So I don't believe that's something we have. We do have mixed categories, and so for a number of the mixed categories, we try and represent what we believe is common in the waste stream. But I think we just feel like the users of the tool in general have a better sense of their material mix than we could estimate. So we try and leave it to the users to do that.
Okay. This attendee is not clear about subtracting greenhouse gas alternative from baseline when prevention is the alternative.
Sure. So I guess maybe I could rephrase it. So regardless of if the baseline has a positive or negative environmental impact, what you're trying to do is the tool is trying to show the difference between what would have happened in place of an intervention and what you did to intervene, and where and how you diverted that material from, often from the landfill, but it could be from a less beneficial practice. And so the alternative is calculated independently of the baseline, but then they're compared. And that comparison allows you to say, by moving from this waste management practice to this practice of diverting the material from the landfill, or a less preferential management practice, I had this environmental impact, or this is the reduction in emissions because this intervention was put into place. And so that's why there is a comparison. There are ways that if you just want to say, what is the environmental impact of me landfilling this material, you can certainly calculate that. And so that would potentially, you would enter both tonnages under landfill on both sides, and then you wouldn't look at a comparison. You would just look at the impact of either baseline or alternative, which would have the same result. And you could say this is the environmental impact of landfilling this material, and then it's not a comparison. There are some reasons that people want to do that, but often people are looking for a comparison, either between years or from what used to happen to what happens today.
Okay, related question. Why is source reduction absent from the baseline table?
I think the thought is that if you were comparing, you would compare something to source reduction. I don't think that we had a compelling reason for somebody to start with source reduction. If there's source reduction in the baseline, that the material wouldn't exist initially, and then it'd be hard to compare that to anything else.
All right. Is EPA measuring bioplastic, i.e. BPI certified? And if not, will they be?
I'm not sure if that's specific to warm. I'm not sure how specific we get in the warm plastic material category. So this is a good opportunity to talk about the warm documentation. So within the warm tool, we do get a lot of questions, and almost always the first initial response is to ensure that the stakeholder has reviewed the documentation chapter that's specific to the material or management practice that they're interested in. These are, really lengthy documents with a lot of detail. We try and be as transparent as possible. And so a lot of that information is in the documentation chapters. And so that's the type of question that I would, first reference the documentation chapters on plastics to see if bioplastics are mentioned or modeled. And if not, then it would be, a question if the stakeholder feels like it needs to be, we'd be interested to know where they believe that data is and who are the, maybe researchers or companies that we could talk to about getting that. A third part of that is it a common practice now? And if it's not widely used material, or the material isn't commonly going to a specific management practice, it may not be included. We usually wait until it's a bit more wide stream rather than trying to anticipate what will happen.
So I see PLA under the plastics. Is that polylactic acid, which is a compostable? And right now there's no model for that, but there could be at some time in the future.
So it looks like PLA is the only plastic that's modeled for composting, if I'm reading the screen correctly.
All right. Oh, yes, it is. So it is. Okay. Okay. Why does yard trimmings have a positive impact while food has a negative impact? Both are considered organic material, correct?
Yeah, this is a good question and something that we is a debate. So I think it's this one where it would show, yeah. So for yard trimming. So I think it's talking about the landfilling of yard trimmings. Is that the question?
It doesn't mention that, but we can assume that.
Okay. So basically, the way that that yard trimmings is modeled is when yard trimmings, branches, and things are put into the landfill. There is a carbon storage component to that, where they are stored in an anaerobic condition where carbon is trapped rather than released to the atmosphere. Whereas if that branch or material would have decomposed, outside in normal conditions, there would have been a carbon release. And so yard trimmings actually get a benefit because it is carbon that is sequestered indefinitely. This is not the same way that every tool models the situation, but it's the best scientific evidence we have is this is what happens, and that that's the way we model it. So it can make some alternatives to landfilling of yard waste look less beneficial, and we certainly hear that complaint from supporters of compost or anaerobic digestion or others. But this is just simply the best data that we have, and we've had researchers look at this topic a number of times. We do have some documentation online that's specific to this topic, and so if this user or the stakeholder that asked that question, you may want to follow up, and I could send you that in an email to explain the methodology there.
Okay. May not be able to answer this one, but I'll ask it. Has anyone done an analysis to determine the CO2 and methane reductions of incinerating all trash going to landfills and the emissions of incinerating same versus the equivalent energy generating need of oil and coal and the emissions of those forms of energy?
So you certainly could do that without too much difficulty, I believe, using the tool. So you would just use, you could use the EPA facts and figures report for the amount and put that into combustion. There are a couple ways you can tailor the results of combustion, and then you would need to choose a state or region that generates all or predominantly all of their electricity through coal. And so, I mean, it's not something that I have done or talked to a stakeholder about doing, but it seems like something that should be doable through the tool. So if you want to take a look at the tool and give it a shot, I'd be happy to provide feedback on what you come up with and what else you could do.
How would you model single stream recycling if you don't have all the material weights separately?
So we do have, I'm not sure if it'll, so we have a category that is mixed recyclables. So here's mixed recyclables. So that's one way to address it if you really wanted a quick snapshot. A potentially better way would be to know all of the, you could do, we also have mixed MSW if you're not doing any type of separation. But I mean, it's if you want to get an accurate result, you know, it's potentially you need to do a waste audit and try and get some type of estimate of what types of materials you're getting and what quantities, and then you could apply that to the overall tonnage.
Yeah, and some states have done waste characterization studies, and they've looked at, you know, they've surveyed the MRFs in their state or region, and they determine percentages of commodity in a single stream mix, and so you can base those percentages.
And see if how much you believe that your state would be represented by the state and that carried out the report.
Okay, are the icons used with the greenhouse gas equivalency tool open to be used?
Usually the answer to that is no. But let me pull up. And so do you mean like the car or truck or house?
It doesn't. They don't elaborate on that.
So I think what I would say is the EPA logo is something that can almost never be used. There are few times when permission is given for that, but things like this that are generic, like the house or car, I don't think are in any way proprietary. So I believe that those could be used to help provide an example of what the equivalency is.
Given the EPA food waste hierarchy, what happens in the model if a donation, quote unquote, rescue takes place?
That's a good question. So that is something I could have included on what we're working on for 2019. Currently, we have some guidance online about how you can estimate the avoided landfill emissions if you donate food. But what we've heard from stakeholders and agree with is, you know, that's really only part of the picture of the avoided landfill, that really there's a lot more benefit happening there that we need to try and capture. And so we're working on a methodology and got some data from Feeding America about loss rates. So you'd be able to incorporate a loss rate. And then we would suggest that a user calculate the benefit from avoided landfilling and then compare that to the benefit of source reduction. The idea is that in the best case environmentally, that the food that was donated would offset some food that was produced and purchased, and that would be equivalent to source reduction. The issue is that not all food that's donated is replacing food that would be purchased. There are some, you know, instances where donated food, the person who ate that food wouldn't have instead bought food, and so it's hard to calculate the percentage of donation that's source reduction. That's been our issue in directly calculating donation in the WARM tool. But we can do, if you have the lower bound, which is avoided landfill, and the upper bound, which is source reduction, you could at least provide a range of benefits to your users. And so that range would give stakeholders an idea of what the environmental benefits are of donation, and that's hopefully going to be released later this year or early 2019, so that users can at least estimate using the tool, although you can't calculate donation directly in the tool currently or likely in the version 15.
Okay, and just please confirm that the data entered has to be a weight-based and not a volume-based. They would have to be converted prior to entering
Correct.
the data.
Weight-based in short tons.
Okay, will you be adding data for funding LCA data for plastic resins other than PET and high-density polyethylene for future versions?
So it's I don't know that. We get funding annually for a number of different things, and the priorities of what's funded within the funding for our division and then the tool specifically isn't that specific. So I can say in the 2019 updates that we won't do specific research on either of those areas, but they could potentially benefit from the overall annual update where we update the background emissions factors.
Okay. Does the EPA WARM model allow for modeling of reduced greenhouse gas emissions from green purchasing or purchasing recycled paper, for example, over virgin paper?
No, I believe there's some other tools that go into purchasing a bit more. You could do some of that potentially, but that's not the primary area that WARM functions. So you'd likely need additional data from what's in the WARM tool.
Mm-hmm. Is there a mailing list you can join to be notified of new updates of the WARM model?
There currently isn't, but that is a good idea. I'll take a note of that and see what options we have for creating such a mailing list.
Can one alter any emissions factors, i.e. for energy, to reflect local emission factors?
So at this point, the closest we have is the regional based on your state. I think one of the benefits that we're hoping for moving to OpenLCA is that a user could extract the data from the WARM tool and replace the energy emissions factors with those specific to their town, municipality, or state, and get a more accurate result, but that's not something that currently exists.
Okay, this one wants you to go through another example, and we do have time, so I think we can do this. Can you walk through an example of recycling OCC and then putting the outputs into the greenhouse gas calculator?
Sure. So go back to the tool. So take this out. So we have corrugated containers here. Is there anything? Did they say anything specific they want to see? Any specific management practices?
I would say recycling.
Okay. So we can stick with 100. I can split it up a little bit. So let's say that we ended up going from purely landfilling initially to recycling 50%. Still, let's say 20 tons going to landfill, 20 being combusted, and then 10 source reduction. So you got a little more efficient in your process and received less paper because you moved to some other technique. Some is still going to landfill. 50% is recycled. And so here's a scenario you could do for OCC. Don't need to. So if we go to default distances, that just gives the estimate of 20 miles. I think this is important because I think often users overestimate the impact that transportation at the end of life has on the overall impact of the emissions. And so it's good to be able to change these and look at those. We did. So then we go next. So we'll stick with metric tons of CO2 equivalent. So here this goes the weights and the overall from landfilling. So there's a positive 24 metric tons of CO2 equivalent. Here, so in something I'll show then is, so this is a sum of these different management practices and tonnages, all summed to this negative 216, and then the comparison negative 216 minus 24 equals to negative 240. So, often it's important to know not just the overall difference you're making, but specific to the different management practices. And so here, so I went to tab, here's the summary, here's the overall results you get, and then within analysis, you will see a breakdown. In the future, down here as well, we hope to add some visuals so that you can see some, bar graphs or pie charts about where your different emissions are coming from. So if you went to the alternative where we had a number of different emissions, you can see then where it breaks down. So here it would say the source reduction, and then the GHG's impact from source reduction. So there was 10 tons, and that had an impact of negative 55 metric tons of CO2 equivalent. Recycling, 50 tons, and then negative 156 metric tons of CO2 equivalent. So here is actually where you would see the specific breakdown if you did multiple management practices beyond just one. If you did just one, then it's pretty clear from the summary. But if you did multiple, and so each of these tables does a comparison within the management practice between alternative and baseline.
Okay, good example.
Oh, and then I think we wanted to put it into the GHG equivalency calculator too, correct?
Go ahead.
Okay, and so we have negative 240. I'll do it from the Google search again. So do the Google search. So this is on the page. We have metric tons of CO2 equivalent. It was negative or 240. And so in this example, here are the equivalencies of moving away from landfilling the OCC.
Okay, good. Okay, is it possible to just access the WARM data directly in OpenLCA as a database and use it alongside other LCI data as opposed to the front-end tool, which is based on OpenLCA?
That is our goal in the short to medium term, so that users could have access to that directly rather than going through the tool at all, if that's what they wanted. There are within the OpenLCA user interface, there's a button that says basically extract data, and so what we need to do, going into version 15, is have that be able to be extracted by users and used directly. Likely you won't be able to make changes and go back into the user interface. That once you extract the data, you would need to have your own method of using that data outside of the tool, but that is the goal of ours in the short to medium term.
Okay. What percent of the landfill gas capture does the model assume?
So that's a documentation question within the further characteristics where you make some choices to make it okay, so here within the landfill gas recovery area, you can see here are the assumptions made, and so depending how aggressively your system is able to capture the gas, you would choose one of these 4 options. And then I believe for many of the construction and demolition materials, you do not have the capability to assign methane capture at the C&D landfill, I believe. And that's one thing we'll look at in the upcoming memo to see if that still is true, or if we need to add gas capture to C&D landfills.
Okay, this is a comment that bioplastics are not plastics, they are compostables compared to fiber-based or 100% plastic material. They should be separate.
So they shouldn't be grouped with the plastics?
Correct.
Okay, I'll make a note of that.
Okay. So regardless of the baseline management practice, it is being compared to landfilling. This relates back to the baseline scenario of combustion being negative CO2 emissions.
Combustion being negative CO2?
Yes.
So I think the impact of combustion would depend on the material. So we'll go to the comparison I showed earlier. So a lot of these don't show a strong impact of combustion, but I think it's here. And so for some, it's positive, and for some, it's negative. And so that is a net positive or net negative. So it's not taking into account just one emission from that process, but it would have to do with both the emissions from that process, including transportation, to any energy offsets or potential recycling that happened after that combustion process. And so all those would be lumped into one number in this chart, and it could be net positive or net negative depending on the material.
Okay, I guess, I'm sorry. Are you done?
I was just going to go back to the last comment and say, for comments like that about bioplastics and where it should be grouped, the best way to record those types of comments is to email the group ORCR warm questions. I can put that up again before we go, and provide that comment as specific as possible about where you think it should go instead, and why, because then we can document that and make sure it's discussed when we do any future updates.
Okay. Is the warm model moving towards anything in support of the circular economy trend?
Well, I mean, there are components of circular economy. I would say our office, I'm in the Office of Resource Conservation Recovery, we focus on sustainable materials management. We feel like sustainable materials management and the circular economy are aligned in many ways, except that sustainable materials management considers highest and best use based on life cycle information. And so that may or may not be a circular solution. There may be situations where, landfilling a material or not reusing it in the same way it was used before, may be a best option. But regardless, there are things within the recycling category where circular economy is incorporated. For example, for plastic bottles, there are some assumptions about how many times a plastic bottle can be reused if a material is recycled into the same type of product or not, are things that are included in some material categories for recycling. So I do think that they're aligned in ways. If you feel like, if stakeholder feels like there is a gap where there's a circular economy solution that's commonly happening that you can't model in warm, I'd be interested to hear about it.
Okay, is the raw data behind the warm tool, such as energy consumption for aluminum can recycling, available anywhere?
Yeah, the warm documentation. So we always point stakeholders there. Usually that's sufficient. There are some situations where a stakeholder really needs, the specific level of granularity where they need to dig into it, and that may not be available. But Our data is pretty transparent and available in documentation, so take a look there first.
On a related note, to avoid it disposal, has any thought been given to incorporating reuse as a materials management category similar to source reduction? Or is that included in source reduction?
Yeah, so it does sometimes, I think, depend on the material, but that source reduction often can be used to model reuse, especially if however you're using things offsets something that would have been produced and purchased in the marketplace, then that's exactly what source reduction is intended for.
Okay, I think I know this answer. Can fractions of short tons be entered, for example, 0.1 short ton or 0.01 short tons? Does that have to be a whole number?
Let's try it out. Yeah, it looks like you can do fractions.
Good. Is it common for users of the WARM model to use calculated greenhouse gas reductions in their greenhouse gas inventory?
So this is a common question. WARM was not designed for that exact use. So there are some inconsistencies with that. So the question we get a lot is about scope 3 reporting, where a company wants to report on a specific annual year and the reductions. We have some documentation that provides some language about when that may or may not be appropriate. One thing to consider is that the WARM results incorporate GHG impacts that extend out, up to 100 years into the future. And if you're trying to claim that you made a specific reduction in a specific calendar year, that can be a bit complicated. So I would say it's not specific. WARM wasn't specifically designed for that. I know that people do use it. I think it's about being transparent about what you used and why, and including that in the report, any reporting you do.
Okay, is it possible to use the model outside the United States? Would it need to wait until open LCA is available so that emission factors can be adjusted to reflect the nature of the grid? Example, the grid in Europe.
Yeah, that's a good question. I think once the emissions factors within OpenLCA are able to be extracted and changed, that would be ideal. I know that Canada used the WARM tool emissions factors to develop their own tool. I think it hasn't been as updated and added to as much as ours, but it was created. I also know that there's some researchers in countries that just don't even have the data available to do this type of calculation, have used the WARM tool and then looked at specific parts of the calculation that may not be relevant for their country and their setting, and have tried to write and be transparent about why they use the tool and when it may not be appropriate. But it still would provide an estimate, but it's definitely a valid point that there are differences depending on your country and electricity grid.
Okay. Is transport to end markets from MRFs factored in? Would this include shipping to markets overseas for materials like paper and plastics?
So there are these are the assumptions that come into that there are 20-mile distances on average. So if that's not the case, then you would need to change that. There are limitations on what types of transportation are incorporated. I think they are truck. So, we had some people who are interested in if they were using barges and other things. I don't think it gets that complex. It is something, if you wanted to start to look into that, you would likely want to look at the documentation around the transportation for the management practice or material. It can be fairly small, but the point is valid. If you end up shipping it internationally, that could significantly add up, even if it is on a large container ship. To what degree, I'm not sure.
Okay, last question. If you use a previous version of WARM, can existing data analysis be migrated into the newer versions?
So we do have some older versions of WARM available. There are some reasons why users want to continue to use those, whether they did initially and want to keep that as a baseline and continue to compare against that, or the emissions factors or management practices have changed since, and they're not able to do what they were able to do at one time. This is a tool. It is iterative, so this version 14 built off all the versions before it, and likewise, version 15 will do the same. We feel like version 15 will have the best, most up-to-date data, and so in most situations, that's what we would recommend that users use. But there are reasons people use the old tools. We do keep some information, including background information, available on those in case somebody wants to use an older version.
Okay, great. All right, great questions, everybody, and thank you for answering those, Nathan. So we're going to close out the webinar. So this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thank you again for joining us. We hope you'll join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. So thanks again, Nathan, and have a great day, everybody.